Welcome to our deep dive into carbon sequestration on land, focusing on nature-based solutions and the complex trade-offs involved in land use. As climate change accelerates, the European Union has set ambitious targets to become the first climate-neutral continent by 2050. Achieving this goal requires not only reducing emissions, but also enhancing the land's ability to absorb carbon dioxide. In this video, we'll explore the key questions and answers around carbon sequestration, the role of different landscapes, and the critical decisions facing policymakers. Let's begin by understanding why carbon sequestration is at the heart of Europe's climate strategy. European Green Deal is a bold initiative aiming for carbon neutrality by 2050. To get there, the EU is revising climate and energy laws, including a commitment to cut greenhouse gas emissions by at least 55% by 2030 compared to 1990 levels. Natural carbon sinks like forests and peatlands are crucial in this effort, but many are under threat from agricultural expansion and logging. The challenge is to balance land use for food, energy, biodiversity, and climate goals. This means making tough choices about how land is allocated and managed across the continent. Nature-based solutions refer to strategies that use natural processes and ecosystems to address climate challenges. In the context of carbon sequestration, this means restoring and conserving forests, wetlands, and grasslands to absorb more CO2 from the atmosphere. These solutions not only help mitigate climate change, but also support biodiversity and ecosystem health. The EU's approach emphasizes integrating climate protection with biodiversity goals, ensuring that efforts to capture carbon do not come at the expense of nature. There are two main ways to tackle atmospheric carbon: reducing emissions at the source and increasing the capacity of natural systems to absorb carbon. Land-based solutions, such as maintaining healthy forests and peatlands, can absorb significant amounts of CO2. However, nearly 60% of the world's land is under human pressure, which reduces its ability to act as a carbon sink. This highlights the urgent need to protect and restore these vital ecosystems. EU Green Deal sets clear objectives for carbon sequestration. By 2030, the goal is to store 310 million tons of CO2 in natural sinks across the EU. This requires expanding and improving the condition of ecosystems, especially forests and wetlands. The Green Deal also includes the biodiversity strategy for 2030, which aims to reverse ecosystem degradation and benefit people, climate, and the planet. Achieving these targets will demand coordinated action across all member states. Key component of the EU's approach is the new forest strategy for 2030. This strategy focuses on improving both the quantity and quality of European forests. It includes protecting primary and old-growth forests, reforestation, and planting an additional 3 billion trees by 2030. These actions are designed to increase forest resilience, combat climate change, and reverse biodiversity loss. The strategy also sets binding restoration targets for specific habitats and species. EU's nature restoration law introduces binding targets for restoring degraded ecosystems. By 2030, at least 20% of the EU's land and sea areas should be under restoration measures, with the ultimate goal of restoring all ecosystems in need by 2050. This includes actions like rewetting peatlands, renaturalizing rivers, and replanting forests. Progress will be monitored and reported to ensure accountability and transparency. Europe is home to a diverse mosaic of ecosystems, each with varying capacities to sequester carbon. These include forest, agroecosystems, cropland and grassland, wetlands, heathlands and shrubs, sparsely vegetated lands, rivers and lakes, and marine ecosystems. While some, like croplands, are heavily influenced by humans, others, such as peatlands and semi-natural grasslands, retain more natural characteristics. Understanding the role of each ecosystem is crucial for effective climate action. Wetlands, including inland and coastal types, play a vital role in carbon sequestration. Inland wetlands, such as peatbogs and marshes, cover about 2.2% of the EU27 and UK land area, with peatbogs being especially significant for carbon storage. Coastal wetlands, though smaller in area, are also important. However, wetlands are under threat from drainage, land conversion, and climate change, leading to a loss of their carbon storage capacity. Agroecosystems make up nearly half of the EU's land area, with cropland accounting for about 76% and grassland 24%. These landscapes are heavily managed, often with high inputs of fertilizers and pesticides. While their carbon storage potential is lower than more natural ecosystems, improvements in management practices such as organic farming and reduced tillage can enhance their role as carbon sinks. Forests cover about 38% of the EU27 and UK land area, making them the largest terrestrial ecosystem. However, only a small fraction is primary forest, with most being semi-natural or managed plantations. Forests are crucial for carbon sequestration, but their effectiveness depends on management practices, species composition, and resilience to disturbances like drought and pests. Heathlands and shrubs, along with sparsely vegetated lands, are found throughout Europe. These ecosystems cover a smaller portion of the land but are important for biodiversity and, to a lesser extent, carbon storage. Heathlands and shrubs have experienced significant losses due to land use changes, while sparsely vegetated lands have increased slightly, often due to fire. Marine ecosystems, including the Northeast Atlantic, Baltic Sea, Mediterranean, and Black Sea, cover vast areas and play a role in carbon cycling. Freshwater ecosystems such as rivers, lakes, and floodplains are also significant. In the EU27 and UK, rivers have a total length of 1.3 million km, and lakes cover 84,000 square kilometers. These water bodies contribute to carbon sequestration, especially when connected to healthy riparian zones. Understand carbon storage potential. It's essential to look at the spatial extent of different ecosystems. In the EU27 and UK, cropland and forests each cover about 36% of the land area, grasslands 11%, and wetlands, rivers, and lakes around 2% each. Urban areas make up about 5%. This distribution shapes the overall capacity for carbon sequestration across the continent. Each main ecosystem can be broken down into sub-ecosystems, such as broadleaf forests, coniferous forests, peat bogs, and salt marshes. These sub-ecosystems vary widely in their carbon storage capacity. For example, peat bogs and salt marshes have some of the highest storage values per hectare, while grasslands and sclerophyllous vegetation store less. Understanding these differences is key to targeting restoration effort. Potential carbon storage of EU ecosystems is estimated at over 13 billion tons of carbon, or 48.5 billion tons of CO2, if all were in an intact state. However, the actual storage is likely lower due to widespread ecosystem degradation. Most ecosystems are not under strict protection, limiting their ability to function as effective carbon sinks. This gap between potential and reality underscores the need for restoration and protection. Recent reports indicate that 81% of protected habitats, 39% of protected birds, and 63% of other protected species in the EU are in poor or bad condition. This poor state affects the ecosystem's ability to store carbon. While some managed ecosystems like cropland can improve with better practices, the greatest gains come from restoring semi-natural and natural systems. Estimate future carbon sequestration. Researchers use scenarios based on ecosystem condition and protection status. In an optimal scenario where all ecosystems are intact, the EU27 and UK could store 103.2 million tons of carbon annually. However, this is a best-case estimate. Realistic scenarios must account for degradation and limited protection, leading to lower actual sequestration rates. Researchers consider 4 scenarios for future sequestration. 1. All ecosystems are intact. 2. Only 20% are functional due to degradation. 3. Only strictly protected areas contribute. And 4. The share of strictly protected areas increases to 10% by 2030. Depending on the scenario, annual sequestration could range from 28.3 to 378 million tons of CO2. These scenarios help policymakers understand the impact of different land management choices. The optimal scenario, where all 11 key sub-ecosystems are intact and functional, the EU27 and UK could sequester up to 378 million tons of CO2 annually. About 83% of this capacity comes from forests and woodlands. However, this scenario is unlikely without significant restoration and protection efforts, as most ecosystems are currently degraded or under human pressure. Assuming only 20% of the designated area is functional due to widespread degradation, annual sequestration drops to about 75 million tons of CO2. This scenario reflects the current reality for much of Europe, where ecosystem health is poor and restoration efforts have not yet scaled up to meet the challenge. If only strictly protected areas contribute to carbon sequestration, the annual rate falls further to about 28.3 million tons of CO2. Currently, only 3.4% of EU land is under strict protection. This scenario highlights the limitations of relying solely on protected areas without broader ecosystem restoration. If the EU achieves its goal of having 10% of land under strict protection by 2030, annual sequestration could rise to about 83 million tons of CO2. This would require a significant increase in protected areas and effective management to ensure these lands function as carbon sinks. Natural carbon sinks face multiple threats, primarily from climate change and human activity. Droughts, fires, storms, and pest outbreaks can rapidly release stored carbon back into the atmosphere. Land use changes, such as converting forests to agriculture or draining wetlands, further reduce sequestration capacity. Between 2021 and 2030, disturbances could cut European forests' carbon storage potential by 180 million tons of CO2 per year. Agroforestry, which integrates trees with crops and livestock, can enhance carbon storage in both biomass and soil. However, climate change poses risks, with yields expected to decrease in southern Europe and increase in the north. Forest fires, droughts, and pests threaten the stability of these systems, making long-term carbon storage uncertain. Peatlands are among the most effective carbon sinks, but they are highly sensitive to drainage and climate change. Lower groundwater levels and higher temperatures can dry out peatlands, releasing stored carbon. Protecting and restoring peatlands is essential to maintain their role in climate mitigation. Coastal marine ecosystems such as salt marshes and seagrass meadows also sequester carbon. These areas are threatened by pollution, eutrophication, and coastal development. Climate change can exacerbate these threats through heat waves and rising sea levels, putting these important carbon sinks at risk. Forests are particularly vulnerable to climate change. Young trees are susceptible to drought, and the overall sequestration potential depends on species composition and adaptability. Abiotic disturbances like drought and wind, as well as biotic threats like bark beetles, are expected to increase in frequency and intensity, reducing forests' carbon storage capacity. Growing bioenergy crops on land that could be used for nature-based carbon sequestration comes with significant opportunity costs. Studies show that natural vegetation on these lands would sequester 66.3 million tons of CO2 per year, far outweighing the net greenhouse gas savings from biofuel production. This suggests that prioritizing natural restoration over bioenergy crops is more effective for climate goals. The EU consumes large quantities of biofuels, requiring millions of hectares of land. If this land were allowed to revert to natural vegetation, it could make a significant contribution to the EU's carbon sequestration targets. Furthermore, alternative energy options like solar-powered electromobility require far less land and offer greater climate benefits. Comparing the climate impact of biofuels and alternatives like solar-powered electromobility, the difference is stark. While biofuels offer some greenhouse gas savings, natural restoration and solar mobility can deliver much greater benefits. For the same driving distance, solar mobility occupies only 2.5% of the land required for biofuels, freeing up land for carbon sequestration and food production. Logging European forests for bioenergy also carries significant opportunity costs. Removing wood reduces the forest's carbon sink capacity. Studies show that using wood for energy often results in a net increase in greenhouse gas emissions compared to leaving forests to grow and sequester more carbon. Building up carbon stocks in forests is generally the better climate strategy. The concept of storage balance helps assess the true climate impact of wood use. It considers greenhouse gas emissions from production, substitution effects, and changes in forest carbon stocks. The less wood removed from forests, the greater the overall carbon storage. For example, using 24 million tons of wood pellets in the EU results in a foregone storage effect of 30.7 million tons of CO2. There's ongoing scientific and political debate about the best way to manage forests for climate protection. Some argue that only managed forests can contribute to climate goals, while others highlight the effectiveness of old, unmanaged forests as carbon sinks. The consensus is that reducing wood extraction and increasing protection generally leads to better climate outcomes. Summary: the EU's goal of storing 310 million tons of CO2 annually by 2030 is ambitious, but achievable with the right mix of restoration, protection, and sustainable land management. Nature-based solutions offer significant potential, but their success depends on addressing threats, avoiding counterproductive land uses, and scaling up protection efforts. The choices made today will shape Europe's climate future. Restoring degraded ecosystems is a top priority for increasing carbon sequestration. This includes rewetting peatlands, reforesting cleared areas, and improving grassland management. By focusing on the most effective ecosystems and scaling up restoration, the EU can make significant progress toward its climate targets. Successful carbon sequestration strategies must integrate biodiversity and climate objectives. Protecting habitats, restoring ecosystems, and supporting species diversity all contribute to more resilient and effective carbon sinks. The EU's biodiversity strategy for 2030 is a key part of this integrated approach. Strong governance is essential for tracking progress, ensuring compliance, and mobilizing investment in nature-based solutions. The EU is establishing frameworks to monitor restoration, report on outcomes, and guide public and private decision-making. Transparent reporting and adaptive management will help keep efforts on track. Innovation in land management, monitoring, and technology can enhance carbon sequestration. From precision agriculture to remote sensing and data analytics, new tools are helping identify priority areas, track ecosystem health, and optimize restoration efforts. Continued research and investment are vital for scaling up solutions. Achieving large-scale carbon sequestration requires the involvement of diverse stakeholders, including governments, landowners, businesses, and communities. Collaborative approaches ensure that solutions are practical, equitable, and widely supported. Public awareness and education also play a vital role in driving change. Land use decisions often involve trade-offs between competing needs: food production, energy, biodiversity, and climate. Policymakers must weigh these factors carefully to maximize benefits and minimize negative impacts. Transparent decision-making and stakeholder input are essential for finding balanced solutions. Regular monitoring and adaptive management are crucial for ensuring that carbon sequestration efforts deliver intended results. This includes tracking ecosystem health, carbon storage, and the effectiveness of restoration measures. Flexibility allows for adjustments as new information and challenges arise. While this video focuses on the EU, carbon sequestration is a global challenge. International cooperation, knowledge sharing, and alignment of policies are essential for scaling up nature-based solutions worldwide. The EU's leadership can inspire similar efforts in other regions, contributing to global climate goals. Sum up: carbon sequestration on land is a cornerstone of the EU's climate strategy. Nature-based solutions offer immense potential, but realizing this requires restoration, protection, and smart land management. Avoiding counterproductive land uses such as excessive bioenergy crops or logging is critical. The choices made today will determine the climate and biodiversity legacy for future generations. As we look ahead, the path to a climate-neutral Europe depends on our collective commitment to restoring and protecting nature. By prioritizing carbon sequestration, integrating biodiversity, and making informed land use decisions, we can build a sustainable future. Let's continue to support policies and actions that harness the power of nature for climate and people.